png. It's in the here. So here. Now, don't forget to add this or make it a habit when using the Pygame to add a dot convert alpha to make the image more optimized and more usable for Python and compatible. So how do we display this on the screen? I mean, yeah, if we run this, nothing happens because we haven't really displayed it yet. So how do we display it? So we will be using the screen now because this is our variable that stores the display. So how do we display? Go to your loop, make sure the indentation is correct. Screen dot blit. So to display something, you'll need the blit function or method. So it will ask multiple arguments. Mostly the two things that you only need is the surface and the coordinates. So the surface is the name of the screen. I mean, the variable name of the thing that we want to display in this current surface. In this case, it's named image. And the coordinates is this the x and y position. Since we will be displaying it, imagine it on like on the edge of the board. Like just put 0, 0. It's a bit more harder to explain, but we want it to display on the edge. Like it will look like this. So it's starting from this point, and it will go like stretching up there. Yeah. So now we have successfully loaded an image. So we're done on that part. Now we will be drawing a circle. So to draw a circle, there's actually a built-in function in Pygame. It's called draw. That the draw function. So here, actually, there's a big flaw for me at least. You can only draw a circle and not store it in a variable, which is a bit weird for me. And but it's about the design of the Pygame itself, so it's fine. So now it will be asking multiple parameters for us, arguments, sorry. Surface, of course, we will be displaying it in the screen. The color value, again, that would be the three RGB, like the red, green, and blue. So for now, let's put just 0, 0. And it will be asking us the coordinates, the center coordinate. So for now, we want it to be displayed in the center of our display. So how do we do that? I mean, we can't put like, just divide 600 by 2 and we will get 300 and divide it by 2. But that's a bit more like, hassle. So we will just be using the expositions, like we'll use a variable so it adapts with the actual width and height. So exposition would be equal to width divided by 2. So and also the y position would be equal to height divided by 2. So now if we put it inside here, x position and y position, that's good. And now there's also this radius is like this determines how big the circle would be. I mean, it's in geometry, so for now let's just make it into a constant value like 10 maybe. Then this should work now. And yeah. So once we run this, we should see a black circle in the middle of our window. Look, okay. It's not really a perfect circle, but a circle is a circle. So now we will be creating logic. When it hits the edge, it changes color and bounces off. So we will be creating an animation. So this is my problem with this. So like we can't really create this rect because the return type of this circle method is actually a rectangle. So directly we're manipulating this, but how do we manipulate it? So I mean we could create an animation on like this. Okay, let me just do it. Position plus equals 4. This should be moving from left to right, but okay, that just moved so fast. So there's actually a problem here that we forgot to add is how many frames that we want to display per second. So we will be creating the clock. That's the purpose of the clock actually. So we can control how many frames do we display. So now again we just make this clock that tick, and inside the parameter is an integer that we want would be oh sorry forgot 60. So if we run this, we should see it, and it's now running on 60 frames per second. But the circle gets out of the window, so that's not really what we want. So we need to create a logic that when it hits the edge, it changes color and bounces off. So how do we do that? Well, also we should also add this. Okay, look at that. So it's now moving there like that. Now, the problem with this is that we can manipulate it, but you can't really create a logic for it because it's a constant value. So we need to make this 4 not a constant value. So let's make x speed and then y speed equals 4 and 4. So yeah, now we could just declare it here. Now this way we could actually change how fast or how slow it is, or even like bounce back. So I'll just show that in a bit. Now we will need to make the collision logic. So it doesn't move out of the map or the window. Sorry. Okay. So far we have made it move normally because it should move. So now we will be creating the logic that it makes sure that it doesn't go outside of the window. So to do that is if the x position minus the radius. So why did we minus the radius? So actually the value of the it's a bit more complex, but the radius actually affects how far is the x position from the actual like the coordinates. So that's really the most simple explanation from what I can try to elaborate because I don't really fully understand why. Now, if the x position minus the radius is equals to 0, less than or equal to 0, then, but we're not finished, so we need an or because it's better this way. And the x position plus the radius is greater than or equal to the width in the window, then we run this function. So if any of these two conditions are true, then we will run this code. So this means that if the position reaches the edge or like the outer edge here from the left to right, it will run this code. So we want it to bounce off, right? So now we will be making sure it bounces off. Okay. Now we want it to bounce off. So x position, no, I mean, sorry, x speed minus equals x minus speed. So actually this is wrong. Why? In many levels, it's just like, subtracting the actual current value of the speed. So we don't want to do that. So what we want to do is turn the positive number of 4 into negative so it can move backward. So what can we do? We just put a negative sign and then x speed and it should do the trick. So if we were to hit it, right now we need to like remove this. I think that's going to be manipulating that. Okay, boom, it should go back and forth, back and forth. So we've created the animation and the collision logic for the X speed. So now just copy this code again, and this time do it for the height. Then, okay, so this should still work from what I can recall. Now, let's see. So if you're still confused on what this actually does, what it does is just convert the positive number of 4 into a negative. Since increasing the speed or increasing the position of x by adding 4 moves it to the right, by turning it into a negative, it decreases the position, not the actual fighting with the, like just decreasing it and then changing it rather than subtracting it. Yeah, like it's changing the value to a negative number, to a positive number to a negative number. That's what really it does. Now we have created the collision logic for both, so we can also do this for the y speed, y position as well. Should work, and I hope. Okay, now the ball should bounce back, whatever direction. I mean, the window is so small, that's why it's has no multiple weight. But yeah, we can just increase the window, I guess. Should still be fine. Yeah, that. Boom. There we go. We've created a simple animation in collision logic. Now we want it to change color whenever it hits an edge. So right now it bounces off, but it doesn't change color. So this is where the random int will be appearing. So remember that it asks for 3 integers instead of a tuple, which represents the color. So we should make that into a variable, call it color, and a tuple with 3 values. For now, let's just store it in like this. And you can replace this with the color and it should still work. There we go. But now we can't really just like, change it mid code like this. So that's not really practical. We don't really care what kind of color it changes to, so we can use the random and to just manipulate whatever inside of this. So it's actually in the last weeks. So but this time let's make a function for it. A function that changes the color of the circle. So now let's create a function for that. Change color. We will be declaring three variables. So the reason why I'm able to name it RND instead of rand int is because I use the as RND. So yeah. So now just we want to return three integers, so we'll need three values. Now we can just put it here. And now after that we could so it changes color when we bounce this off. So we will have to go here and then color equals change color function. So whenever this logic is true, it will return a new value for color. There we go. So now if we run this, it should work. Change this color and yeah. So yeah,